Okay, we're on chapter 12, which is actually a chapter on moles, and we'll learn about what that is later on, and stoichiometry. But what we're going to do in the beginning to get you ready for this chapter is to review some problem-solving skills that we've already learned. So, we're going to review some more things. These are other things you need to know for this unit, like an atom, a molecule, the difference between those two, scientific notation, atomic mass, dimensional analysis, or conversions, and how to be a problem solver. So first, an atom versus a molecule. An atom is the smallest particle of an element that retains all the properties of that element. An example would be if we have a helium atom. Okay, it's just one particle. Or a molecule is two or more atoms bonded together. So an example of a molecule would be O2. It's two or more bonded together. All right, so we're going to look at this equation here and decide if things are an atom or a molecule. So zinc would be an atom because it's just one. HCl would be a molecule. Zinc chloride would be a molecule. And hydrogen gas would be a molecule because it's two hydrogens stuck together. Okay, we've been over this before. This is pretty easy. The next thing we're going to talk about is scientific notation. We've done this before. You should remember it, but scientific notation is an easier way to work with very large or very small numbers. And remember, if we move the decimal to the left, our exponent is positive. If we move it to the right, the exponent is negative. And my little hint, Lindsay Parker is really nice, so you can't forget that one. All right, so right here, our decimal is, we start where our decimal is, and we're going to count how many times we move it. 1, 2, 3, 4, 5. So this would be 4 times 10 to the negative fifth because we moved the decimal to the right. And the same thing here, our decimal is here. 1, 2, 3, 4, 5, 6, 7, 8. So we get 2.45 times 10 to the 8th because we moved the decimal to the left. The important thing also to remember is how to put this in your calculator. So if you're using your TI calculator, your TI-84, then you're going to use that button that says EE. So you would enter this number as 4 and then that EE button and then -5. And that puts it in there for us. First, I want to talk to you about my 5 steps to problem solving. And this is just something I've come up with over the years to help students solve problems. Sometimes they have trouble knowing what to do or where to start. So the first thing I always say is identify the unknown. What am I asking you for? What are you looking for? So I always put a box around that unknown. The next step is to identify what is known or given. So we're going to underline those. Whatever information we give you that's important, we're going to underline it so that we can see it. Sometimes I also like to list these out to the side, like variables, x equals this and y equals this. So that is very helpful. The next thing is to plan a solution. So once you know your variables, what you know, what you don't know, you plan which equation you need or what method you're going to use to find the answer. After that, you're going to do your calculations. Be careful with your math. Don't skip steps. Show your work so you won't make a silly mistake, things like that. And last, always double check your work. Make sure your answer makes sense. Make sure you didn't make a simple mistake. Check your work and label your answer. Don't forget how important that is. Now we're going to talk about dimensional analysis, which is a way to convert from one unit to another. And we did this earlier in the year, and we're going to be using it for the rest of the year. It's very important in chemistry, and so you have to be comfortable with it. We're going to review it. Dimensional analysis is a lot like fractions. So if we had 2/3 times 3/7, if we put those all together, we'd have 2 times 3 over 3 times 7. And because there's a 3 on the top and a 3 on the bottom, they equal 1. And so in math, you usually learn that they cancel each other. They actually equal 1. But either way, you're left with 2 times 7 and 3 over 3. And if 2 times 7 times 1 equals 2 over 7. So we're basically canceling these numbers out. So when we do this in dimensional analysis, we're going to focus on units and canceling units. The steps for problem solving that we learned earlier are to help you set up the problem. So I'm going to write that down. They set up the problem. What we're going to do next is dimensional analysis. So I'm going to go through the steps of that and what we do once we know what we have and what we are working towards. Then what do we do with it? So in every problem, you're going to have something that you know, right? And we said we're going to underline it, and that's where you start. So I'm going to give you an example of just a simple example of converting 36 inches to feet. And this time you just watch and don't necessarily write it down, and the next time you'll write it down. So we always start with what we know. We know 36 inches. And if it's not a fraction already, we're going to make it a fraction by putting it over 1. So this is what we know. Okay, it goes on top. Then we're going to make a fraction, another fraction. Whatever is on top, I say this a lot, whatever's on top goes on bottom. So we're not going to put the number on bottom, but we're talking about units. We're canceling units. So our inches has to go on bottom because it was on top. And oppositely, if it was originally on bottom, then when we're converting, it would go on top. They have to cancel. We have to divide them. Okay, so then we put on top what we're converting to. So this one is what we're converting to. Now, we're not always able to do this in one step. If you're not, then break it down into small steps. Okay, then I'm always going to ask you, which of these is bigger? Well, a foot is bigger, so whatever is bigger gets the 1. So whatever is bigger is 1. And then we put the conversion factor in the other side. And then you make sure you've canceled your units. So here we canceled inches and we're left in feet. And then we're done. We would do the calculation. And you always multiply across the top. So we're going to multiply these and divide by the bottom. So in this case, we're going to say 36 divided by 12 for our answer, which is 3 feet. Now you can use a calculator to do this calculation if you need to. Here is our first example. It says convert 0.25 miles to inches. So just like we learned in problem solving, this is what we know. This is what we know, and this is what we are looking for. You always start, I'm going to say some of these words over and over, and you'll be able to do this in your head by next week. You'll be saying these words in your sleep, and you'll be like, Mrs. Parker's in my head, and I can't get it out. So, but it's going to help you solve these. So the first thing I always say is, what do you know? Start with what you know. We know there's 0.25 miles. Okay, and we're going from miles to inches. I don't know how many inches are in a mile, but I can convert miles to something else that I know. So miles is on top, and we're going to cancel units. So if miles is on top, basically this is over 1, then we have to put miles on bottom so that those units can cancel. Okay, and then we're going to go from miles to feet because I know how many feet are in a mile. And then I always ask you this, which is bigger, a foot or a mile? And you would say a mile. So that's whatever's bigger is where our 1 goes. And then we put our unit in the other. There are 5,280 feet in 1 mile. And now we're in feet, but we're not done because we're going to inches. So since feet is on top, feet has to go on bottom, and then we can go to inches. What is bigger, a foot or an inch? A foot, and that's where our 1 goes. So there's 12 inches in 1 foot. Our feet have canceled, and our answer will be left in inches. Okay, now you can use your calculator to do the calculation. And whatever's on top, it's just like a fraction. You multiply by whatever's on top, you divide by whatever's on bottom. Be careful when there's actual numbers on the bottom to divide by each one. So go ahead and put this in your calculator and get an answer. So see if you get the same thing as I get. Okay, I got 15,840 inches as my answer. And let's go try another example. The next example is if an inchworm inches at 5.6 inches per minute, how many feet will the inchworm travel in 2 hours? So now we have 5.6 inches per minute, so 5.6 inches per minute. And we also have 2 hours. Now we can't put 2 hours in there yet because we're in minutes and we need to be in hours. So I'm going to convert minutes to hours. Okay, which is bigger, a minute or an hour? An hour, that's where 1 goes. And there's 60 minutes in 1 hour. Now we've canceled our minutes. Okay, and so we're in inches per hour. Now I can multiply by my 2 hours. I've canceled my hours and I'm in inches. But the question wants to know how many feet will it travel. So again, one more conversion. We have to go from inches to feet, right? Inches is on top, so it has to go on bottom here. And then we go to feet on top. Which is bigger, a foot or an inch? A foot, and that's where our 1 goes. And there's 12 inches in 1 foot. And we are now, because we've canceled our inches, in feet. And that's what we need our answer in. Feet. Okay, so we're going to do this calculation. In your calculator, you're going to do 5.6 times 60 times 2 times 1 divided by 12. Okay, because 12 is on the bottom. So try it and see what answer you get. I got 56 feet. It's important for you on these examples to really try it on your own and then watch mine so that you make sure you're doing it right without me helping you. Okay, we have another example. Well, let's get to it. The next example is to convert 155 grams per centimeter cubed to kilograms per liter. And for some reason, these throw y'all off a little bit, but you always have to make a fraction out of them. So start with what you know, 155. Now grams is going to be on top, and centimeters cubed is going to be on bottom. And then we're going to kilograms per liter. We're going to remind ourselves what we're converting to. So I always do that by saying grams goes to kilograms and centimeters cubes goes to liters. Just so we keep that in mind as we work. Okay, if you have a unit on the top and the bottom, you have to pick one of those and convert it first. So I'm going to start with grams, and grams goes to kilograms. So grams is on top, therefore grams goes on bottom, and we can go directly from grams to kilograms. Which of those is bigger? A kilogram. And how many grams are in a kilogram? 1,000. Okay, now we've canceled our grams, and we're in kilograms per centimeter cubed. So the next part is going from centimeters cubed to liters. Centimeters cubed is on bottom, so we have to put it on top. And we're going to go from centimeters cubed to milliliters. And I know I taught you this before, but you might not remember. 1 centimeter cubed is 1 milliliter. They're the same size measurement. Okay, so now we've canceled our centimeters cubed, and we're in milliliters. And so we have to go from milliliters to liters. Which of those is bigger? A liter. And there are 1,000 milliliters in 1 liter. So in this example, we get 155 kilograms per liter. Sorry about my phone going off. I forgot to turn it off, but it's off now. Okay, now you're not always going to get the same number answer that you started with. It just happened in this example. Just make sure you take your time and do the conversions correctly. That's all for this section. If you have any questions, you can email me from your school email or ask some of the older kids to help you, but you need to be able to do this on your own. It's going to be very important